Hello, and welcome to this video on finding the inverse of a 3 by 3 matrix. And although in a subsequent video I will show you how to do it on your calculator, you also need to know how to do it by hand. Since, for example, they might ask you to and show the stages in the working, or a matrix might include algebra, in which case you can't actually do it on the calculator. There are 5 steps to finding the inverse of a 3 by 3, which we'll go through one by one. Step 1 is to find the determinant. Step 2 is to construct the matrix of minors. Step 3 to construct the matrix of cofactors. Step 4 to transpose the matrix. And then finally, step 5 to divide by the determinant. So we're going to find the inverse of this matrix M, which is a 3 by 3 matrix. Step 1 is finding the determinant, and it's given by that rather complicated looking formula there. But what essentially we're doing there is we're multiplying A, the top left element, by the determinant of the 2 by 2 matrix you get by crossing out the row and column that has A in it, so E, F, H, I. Then we take away B multiplied by the determinant of the 2 by 2 matrix, which you get by getting rid of the row and column with B in it. And then finally we add C multiplied by the determinant of the matrix DEGH, which again is the matrix, the 2 by 2 matrix you get when you cross out the row and column with C in it. So for our matrix M, A is -1. The determinant we want is of -1, -3, 4, 2. We're subtracting B, which is 5, multiplied by that determinant there, 3, -3, 1, 2. And then finally we're adding 4 times the determinant of 3, -1, 1, 4. Again, to find the determinant of a 2 by 2 matrix, we're doing the top left times the bottom right minus the top right minus the bottom left, AD minus BC. And if you follow my working through, the answer is -3. If you successfully work through step 1, finding the determinant, then step 2 is very similar. But in this case, we're taking our 3 by 3 matrix and we're replacing every element with the determinant you get from the 2 by 2 matrix from crossing out each row and column. So for example, in our top left box there, where the element is 5, we want the determinant of 3, -3, 1, 2. For the 3 in the right top box, we want the determinant of 5, 4, 4, 2. For the bottom left, where we're looking at the middle element, -1, we want the determinant of -1, 4, 1, 2. And in the bottom right, where the element is 1, we want the determinant of 5, 4, -1, -3. And if we replace every element with its minor, as it's called, the matrix of minors, we get that new matrix on the right. The matrix of cofactors is very straightforward. All we do is we apply what I've drawn there, plus, minus, plus, minus, plus, minus, plus, minus, plus, to the matrix of minors, which means changing the sign of the top middle element, the middle left and middle right elements, and the bottom middle element. So the 9 becomes a -9, the -6 and -9 on the second row become a +6 and a +9, and the -9 on the bottom row becomes a +9, and all the other elements are left the same. Transposing a matrix means reflecting it in its leading diagonal, which in our matrix of cofactors is the diagonal going 10, -6, -14 from top left to bottom right. So basically each row in our matrix of cofactors becomes a column in the transposed matrix. And then to get our final inverse matrix, we divide by the determinant, which we found in step 1 to be -3. So our inverse matrix is -1/3 of our transposed matrix. And now, in the same way that you used an inverse matrix for a 2 by 2 to solve simultaneous equations, we can now solve 3 by 3 systems of equations with 3 variables x, y, and z. So let's say, for example, that we have this system of equations on the right, starting with -x plus 5y plus 4z equals -1. If you compare that with our matrix M, you'll notice that the coefficients of x, y, z in each equation are the elements in matrix M. So we can write it as matrix M multiplied by x, y, z is equal to -1, 6, 4, where they're the numbers on the right-hand side of the equations. So to solve the situation where we have M times x, y, z equals -1, 6, 4, we can instead multiply our inverse matrix by -1, 6, 4, as shown. And if we use our matrix multiplication correctly, we find out the answer is 6, -3, 5. So x is 6, y is -3, and z is 5. And here are 3 questions for you to try, remembering that a singular matrix in question 3 means that the determinant is 0.